Alright, so now that we're done with the range testing, it's time to break this down. We can take this front part off with a little twist. We flip this over. We're going to find that we have a numerous amount of screws. A total of 12 screws. These screws I can leave alone because they're just part of the pump, but to get the body apart, we're going to have to take out a few more. That's what I'm going to do here. What I'm using here to get this undone is a Phillips head jeweler's screwdriver. Also, you could get this in like a tech kit. And then I'm using some Craftsman Robo Grips to just get enough leverage to start rotating the screw. The nice thing about the jeweler's screwdrivers is they have this thumb piece right here that rotates, so that way I can keep my finger down on top, put as much pressure as I want as I crank on it with the pliers. That's exactly what they're designed for, is being able to put more pressure down on the bit so it doesn't slip and strip. And to keep track of the parts, I'm just going to use this magnetic. There we go. Pretty much the same, which is good because now I don't have to figure out where they go. I'll just pull this slowly off. So now this tether comes off. I'm going to take this off here. Right here is the pump. That feels loose as well. So to take this apart further, we're going to have to take out 3 more screws. These are short and stubby, so the stubby screws are internal. So this whole assembly lifts out. So now we've got the 2 tabs. Looks like this. Yep, that just pops off. So as you can see, this pump housing is all self-contained. The loading assembly is all self-contained. Now you can kind of see what I was looking at before, where there's nice holes. Basically, the marshmallow comes down here, drops down in. It has no way of getting back into the pump assembly because it's just holes there, and then pushes it forward. It's like a scoop design. So now we need to take a look at how I'm going to integrate this. The pump, we're going to just get rid of that because we're planning on going CO2. But now we need to combine this section here. It's all pretty well reinforced actually. I'm going to have to go in and Dremel this out. And then Dremel this as well to line up with the rest of this. And I see that there are some notches here. Ah, there is. Alright, good. So there are some pieces here that lock it in place so it won't rotate. That'll help a lot. A marker, mark out. Trigger assembly down into this area. Now we've got this all nice and marked out. Just to make it super clear. X's where I'm allowed to cut. X's. Let's see if I can actually get. Yes. All right. That also comes out. Now that we have the disassembly done, let's take a look at what we're going to be planning on putting inside here. I've got some nice tubing, super rigid. That's going to be for routing our CO2. We have wire of see, I think this is 22 gauge, different colors, always a good thing to have. Gonna need a soldering iron, gonna need capacitors. So I have, this is a range of, since I build so many different things, just went out and bought a 500 piece kit, because if you're gonna be building a lot, that's the way you should go, is always bulk. It goes from 0.1 microfarad all the way up to 1000 microfarads. 12 volt alkaline battery packs. This is what's going to actually power this. I might upgrade these batteries later. That this was such a small battery. This is usually designed for going into clocks, calculators, some of more powerful garage door openers. We've got CO2 refills, 16 grams. They're threaded, so that way I actually have a piercer that this will go into. And it'll open up the cartridge for us. We got 6 of those. This should fit really nicely into, yeah, we got plenty of room there. Potentiometers. Don't necessarily need this, but it's nice when you're needing to tune timing on a circuit. So we're going to be doing some RC circuits for timing purposes on the trigger, along with a bulk set of resistors. These go from 1 ohm all the way up to 50 mega ohms. More than what we need. Again, just bought this because I'm going to end up using them for the channel anyways. Set of transistors. You're going to need about 4 for this. Battery holders. That's going to be so we can easily change the batteries. You don't necessarily need these, but it's a nice value added. This is a quick lock for the tubing. So into this threaded aperture here, the orange space will grab onto automatically and seal the tubing that we're going to be using. So it makes it nice and clean instead of messing around with epoxy. 555 timer chips. These things are amazing. You can use them for almost anything. A number of hertz, or you can have it time out a certain amount of pulse, which is what we'll be using it for. You can get these in 2 different flavors, single and double. Single, like this one, is 8 pins, and double is a 16 pin. Actually, it might be 14 pin. Nice perf boards. It'll make everything nice and clean and take up less space, so that will be able to fit right in there. Part right here, it looks similar to the one I showed you before, but it actually is a piercing mechanism for the cartridges, so they'll screw up in there, and I don't know if you can see it, a cone in there, a very sharp cone that will pierce the foil on the outside of the cartridge and make it usable. Alright, now for the heart and soul of the project, solenoid valve. This is 12 volt model, just happened to be what I picked out for the project. You can get different voltages depending on what you need, but 12 volt is pretty easily obtainable. Ordered this online. It's a pretty wide gauge. You can also change what this diameter is to whatever you need. I just went with this because that's what I had. These 3 parts are going to be going like this, and then have the tubing coming out this end. It's going to go into, I'm going to try to seal off this area, make it so that way it just lets out all the pressure right there. As discussed before, we might be also adding T and have a tube go to the back of this. First thing we're going to want to do, clear our workspace a little bit here, and we're going to take and start assembling what we need and start testing out all the parts one by one to make sure it works before we actually get it all together. By doing this, we can figure out how much space I need inside the body and where I need to cut things out. That being said, everything's going to be dry fit. I'm not going to be gluing anything. I'm not going to be soldering anything. I'm going to be just linking stuff together by twisting it together and making sure, hey, does this actually work? First test is going to be the test of the solenoid. Nice. Alright, so I was correct. We didn't have quite enough amperage off of one battery, so I put 2 in and now we've got enough. That being said, if you want the battery life to be longer, we can actually add more. So I might even go with 3 or 4. And the way you're getting more amperage, you're going to put them in parallel. So whenever you want to increase your voltage, you put them in series. And what I mean by in series is plus to minus. Then that means, okay, so this is 12 volts. If I went and put them black to red, as it were, then we'd have 24 volts. But if I want to increase the current, we actually put them in parallel. So now, as you can see, black to black, red to red. That means my voltage stays the same because it's the potential across these 2 points. So I've doubled potential amperage. Voltage, you're not going to want to mess around with too much. So if something calls for a certain voltage, you should not go above that operating voltage. If it calls for less current than what you are providing, that is A-OK. The circuit will only take what current it needs. It's also kind of a good idea to not undervolt things, especially if it's a logic circuit, because if you undervolt it, it'll also act a little bit weird and possibly get hung up in a certain state that you don't want it in. Again, with amperage, do as much as you want, it's not going to care. It's just going to last longer the life of the battery. So we've got 2 batteries, we've got the solenoid. This has come fit with some plumber's tape. Plumber's tape is always good for any type of gas handling or liquids handling, because it'll actually help give you a nice seal between your threads. Plumber's tape, super cheap, just a little bit left over from replacing the shower head. I'm going to pull it really tight. It's that thread. Just pull it off like that. You'll actually feel it kind of float a little bit. Might actually want to put some more on there. That floated a lot. Not to be used with the movie It, where you'll float too. Yeah, that's a good fit. Well, I might have to go in and undo this later to make sure I'm getting a good pierce. We do that by taking, you'll see there's a notch in here, and we can rotate that, and that'll help push that out. So we can adjust this by sticking in here. We've got our power unit. Momentary switch, which is going to be our trigger, which will be located about here. Use a little cigar trimmer to actually cut our tubing to length. You can use scissors. So that will go into here. And as you can see, it grabs onto it. To get it undone, you push this orange color back. And I cut it extra long on purpose. Yeah, we're going to put this like right up towards the back there.
Here is the fire control circuit I plan on building. You can see the battery on the right with a capacitor to maintain the power when the solenoid fires, because that has a huge draw on current. Next to that is the solenoid with a flywheel diode that protects the circuit when turning off the solenoid, since it is an inductive load. The solenoid is powered by a relay attached to the 555 timer chip, and I use a relay instead of a transistor to minimize voltage drop before the solenoid. The resistor and capacitor connected to the threshold and discharge pins determine the timing, where the time is 1.1 times the resistance and capacitance. The trigger is active low, meaning that when the voltage drops close to 0, the chip activates. And we get this by having a pull-up resistor and transistor going to ground, so that when the transistor activates, it will make the trigger pin go to 0 volts. The rest of this circuit to the left of that is just to smooth and debounce the output of the switch. When a button or switch is activated, it doesn't generally go purely on or off. It tends to flicker a little bit while it's traveling to its final position, and using a capacitor and resistor help to negate that. The diode on this also helps with any negative voltages that might pop up while it flickers back and forth. So let's give this a test.
It's working! Alright guys, so now that we have the circuit built and it's attached to the CO2 chamber, it's time to take it and add it to our gun body. And this will allow us to feed some marshmallows through and see what a good timing for a burst of CO2 looks like. And we'll be adjusting the circuit to make sure it's optimal. What I'm going to do here is take this and basically fashion a nice little adapter. Go like that. And it'll cover this part. And we'll use hot glue to hold it in place. And I should be putting some safety glasses on. Alright, so let's just, do that. Perfect. There we go. All right, well, now that perfectly covers up that hole, this needs to interface with it. All right. All right, so now that at least tacked in place for now. Come on, stay in there. Trying to use these little shards here to kind of build up a structure so that way the glue has something to push against without fully covering up all the holes. Not my fanciest work. That'll do, pig. I think this is low temp glue stick, so it might take a little while for this to really seal up. And by using this quick disconnect here, it's still hot. Wow, is that still hot? I might stick this in the freezer real quick to cure it faster. Yeah, using the quick disconnects, it allows me to actually be able to, if I want to, add it in this T-splice. And the T-splice will allow this to go up into the hopper if I do indeed want it to. I'm gonna stick this in the freezer real quick, and while that's curing, we can power up our circuit and add a little bit of CO2 and see what happens. So now we're going to take our CO2, which I bought threaded ones, so that way it can interface best with this. Before we do this, let's retest our circuit. There's that. Sounds good. With that working, I'm going to take this CO2 cartridge. Seems like this is in backwards. So, if you happen to put in your CO2 cartridge and it just... my camera went dead last time, so let's just show you, bring you back up to speed what happened. While that was cooling in the freezer, because I used a ton of hot glue, I went back to the circuit here. All right, so this is activating now. But when I took the CO2 cartridge
and put it on this, the pressure was way too much for it to be able to actuate. So I found out quickly that I bought the wrong solenoid. It had the wrong pressure envelope. It has an operating envelope of 145 psi. Through my quick research, these are up to 700 psi. My little guy down in the corner will probably be telling you what it actually is. I had to go buy a new one, and it just got here. So this is a new 12-inch solenoid, 1000 psi. So this should definitely do the trick. Do a quick test here. Test in parts, don't test in whole. Oh, that's definitely working. By testing in parts, we can prove that this part right here is good under normal circumstances. That means if I plug it into this circuit, I know for a fact this is a known good. You want as many known goods in your circuit as possible. It makes it very easy to find when you have a problem in your circuit. Instead of looking at the entire thing, you're just looking at, oh, well, I know this is good, I know this is good, but there's this X component between it. I gotta take a look at that. Oh man, are you kidding me? This said it was 1/4 inch. This is not 1/4 inch. And we can double check that real quick. For those of you that don't have calipers, yeah, that's not even close. Problem number 59. I'm gonna have to get adapters. 2 steps forward, 1 step back. Let's go with a 10 microfarad capacitor. Again, probably a little bit of overkill, but right now I'm a little frustrated. So let's go with overkill rather than underkill. So I'm putting it across the 2 terminals, making sure to put this negative line in the right direction. Make sure you keep your eyes away from that when you first power on. And there we go. This power supply is regulated. So it doesn't act like a battery would. If you draw a sudden amount of current, as long as the battery's not dying, it will provide the right amount of current, as long as chemical reactions can keep up, which is pretty much instantaneous in a good battery. But with this, it has to keep up. So we're storing a little bit of extra energy in this capacitor. And so when this opens its floodgates to this solenoid, and there's suddenly a huge draw on the circuit, even though this timer circuit should still be getting enough power, it wasn't, because this was lagging behind just enough that allowed this timer chip to lose power. It would reset the circuit. That's why we saw that quick flicker. This discharges instantaneously, pretty much instantaneously. It's a exponential drop. Starting here, going this way, goes down like that. Any little fluctuations get immediately filled in by this. So it's been a couple days now since I ordered the parts, and they all came in. I wasn't taking any chances, so I bought a bunch. And after quickly comparing them to our device, this looks like it's going to meld up with either of these. This is a little bit lighter, so I think I'm gonna go with this, because these are too much for what I need, I think. So I'm gonna send those back. Jump right in here. All right, so we got 2 of these. Don't need the rest of that. It also comes with some Teflon tape of its own. So I'm gonna use that, because why not? What you wanna do is start it and then pull it tight. And go around at least once and pull it off. All right, so now I'm gonna take this. All right, that's definitely in there. And do the same with the other. And if you find that it's still a little loose, you can always add more than what I'm adding. There we go. Now I'm getting some good resistance off this. Please. You've got to be kidding me. Oh. Holy crap. That is too long. So with the Teflon tape now, I just cannot believe that after like 5 things of Teflon tape, these things are just too powerful. All right, so that's in place for now. The circuit works. It goes for a little too long, but that's okay. What we're gonna do is adjust the circuit to 1/4 of the amount of time that we have right now. That means I need to put 1/4 of the resistance in there. For a monostable circuit, which is what we have here for our 555 timer chip, the timing is T equals 1.1 times resistance and capacitance following the SI standard. That will give you the number of seconds it's going to work at. 100 kilo ohms, so down to 25 kilo ohms. And then we'll start doing assembly of the actual circuit. 33. All right, so we're taking this resistor out. I'm gonna replace it with the 33, then turn this back on. Oh yeah, that's so much better. So much better. Chop this, shorten it up. That'll be the best. This can come right through here, right over to this. I gotta cut this part off, cut out some of this. I'm gonna probably cut a channel down through here and drill a hole here to bring the button right about there. Then this is probably gonna be a circuit about that big, and that can live anywhere in this area. Let's modify this, cutting that part off. All right, so now with this, all the places that have the X are places I can cut. So I think I'm gonna run a nice edge right down this, and then an edge right down this. So let's go with that. And I want these to stay connected. I like to use these fiberboard cutters, because they're less likely to try to send stuff out into your eyes. There we go. Oh, is this even wide enough? Ah, it is. Sort of. The other thing I might have to do to open this space up, we'll take a look with this together, is if you can see here, this area is kind of closed off. I'm definitely gonna, in the back, have to cut open some space there. The battery and the electrical components. Let's see, will this fit? I'm gonna have to cut a notch in here, so let's do that. Was what I said. I need about that length. There we go. Cut like butter. I might have to cut this too, just like the other one. It's this battery that's going to be the problem. That just might be it. I might be able to put it up front here. All right, it's coming together, man. Well, I definitely need this gone, so... There we go. Don't think that's enough space. I don't think that's ever gonna fit. Uh-oh. After taking a look at this and realizing there's a bump out here, I want to basically drill out that spot there. Man, this is using almost every tool in my toolbox. Maybe I should be getting some more tools. Tell my wife that's what I said I wanted. The right size. I think it's gonna be this one. Nice 1330 seconds. Nice weird number. Ooh, I don't know if I can actually fit this into my drill. We'll find out. Hey, it fits. And if it fits, it ships. All right. That's actually really close. I think I should also go a step larger. I think that's good enough. All right, we can move on. Perfect. This is going to be kicking up this way, right? And I want this to go into here and basically push out some CO2 as well. That will help push the marshmallows down in. So I'm going to have to drill again. So let's take a look. You know the perfect way to look at this? Take this, put it in there. All right, that's the right size. So that's 1/4 inch. I should probably actually not do the 1/4 inch right off the bat. I should do a pilot. And the pilot will basically let me do this without shattering it. So there's the pilot. And I'm not going to go right up to 1/4 inch yet. I'm going to walk it up basically. And the reason why that is because if I went right up, you saw how it kind of walked a little bit. Went right up to the right diameter. Let's slip and slide all over the place. All right, let's see how that fits. Oh, that fits great. That's coming out better than I could have expected. So now we have our front tube connected back. Turn that until we hear the click. And then that goes there. This is coming together. So I'm gonna snip that later. For all the things that have been going wrong with this build, this is wonderful. All right, so I need to take out this center area here. Another sanity check here. Always do this. If you're ever in doubt, sanity check yourself. Check yourself before you wreck yourself. As you can see, gives me just enough room. And then the front part can be, let me see this. All right, actually, we're gonna shift this back because I wanna leave as much room for the circuitry as possible. Cutting bit. Also, best practice is to shut off your tool when you're not paying attention to it. Do as I say, not as I do. Well, let's see if that is the right size. It looks like it. Tuck that in as well. Yeah, see, and that is why you turn off Perfect. And since this is right over the handle, I need to make a notch. And this notch won't be seen because it's in the handle, but it'll allow for pass-through of electronics. One of these is going to be using that pass-through. So I'm going to have to figure out how I'm going to do this. Ho 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 ho! We're getting close. Alright, so the battery fits, sort of. Trigger is going to go there. Ah, well, I've got the perfect tool for this. See, I didn't have calipers for the longest time, so I'm used to just eyeballing everything. Well, as part of doing this video for you guys, I've been getting more equipment. Alright, so I'm gonna take a look at that. 15-30 seconds. Yep, let's go with that. Definitely gonna want to take this part out. This is a dumb idea. Yeah, look at that. All right. You should see the grin on my face. Oh, this way. All right. There we go. This cord and this cord, and route it along the other side. Oh my God, I can't believe this is coming together. I mean, I should have more confidence in myself, but come on. We come up with these harebrained schemes off the top of our head and say, oh yeah, it's just gonna go in there and not have any problems. It never works. Almost. This is proof that I'm wrong. I think the next step will be taking this tube out and cutting it at a rather severe angle. So I have E6000. I got... Alright, so one of the things it suggests is roughening up the surface a little bit. Alright, that's rougher. Alright, there's that. And I want to take some and put it on the interior of the crocodile alligator, if anybody remembers that. Alright, so we've got that. Yeah, I think that's the best bet, is to go this way with it. In a second, with movie magic, you will see that I am going to be doing the perf boarding. Set up the system. In the meantime, you can also see there's a power cord here. I'm starting to charge the battery. This connection here is since solidified. So now we have CO2 going into the barrel up front and down in the hopper. Good sign, we got a green light. Yep, everything's actuating properly. What I want to do is load a few marshmallows here and one marshmallow in here after we put the CO2 in. When you do this, if you do this, and I don't recommend it, always wear safety glasses. There we go. Oh, ho, 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 ho. Oh, that's a thing of beauty right there. Gonna push them down in. Are you ready? I think I am. Whoa! That's hilarious. Okay, so let's try this again. Jesus. Oh my God. Okay, that is crazy powerful. That's perfect timing, I think. I think the fact that this locks into grooves on the chassis is going to make it so this isn't a problem. We can go ahead and take this circuit, take it off the breadboard piece by piece, and put it on a perf board. And don't forget that our CO2 is still pressurized, so I need to be careful with this at this point. I should be taking that and actually firing it until it runs out of CO2, so that way the pressure system is depressurized. So as we can see, we have a couple different connections going on. This goes to power, this goes to ground, this comes off here, this can actually be reduced down. So we're trying to eliminate as much stuff as possible and make it compact. That's awkward. Okay. Thing here is known as magic hands, and basically these are invaluable. But it holds everything in place. At least have some way to clamp your work in place, and it'll make your life so much easier. Alright, so let's get our power on here. Alright, let's just go that way. Alright, so what you want to do is you want to bend your socket out. That way it should, once you've done it properly, hang it in place. There we go. See, it's a little loose, but it hangs in place. So now what I can do is I can go here and solder it in place. Alright, so now that's soldered in place, we can start wiring off of it. And that's part of the reason why I took the time to make this as small as I could. So now we're going to transfer this on to here. I like working out from the chip. Other people have different methods. Basically take it apart at a time and you'll get there. Just make sure you leave room for your positives and negatives. Also, just double check that I didn't screw up the circuit. There we go. All right, good. All right, so it's still in working order. That means as I transfer parts over from this circuit, it's going to be 1-to-1. And here's where the planning starts paying off. So I've got 3 components here that go to ground. Don't forget you got 2 sides to these boards. So you don't have to put all your components on one side. You can double side it if you want. It'll make it a little bit fatter, but if you're starving for space, you can do it. Alright guys, hopefully I don't have too much background noise. So I'm going to do a fit check. This is going to be a tight squeeze, but I think we can do it with a little canoodling of these points. So now this is tied in to our power supply. All right. All right, so now I'm going to tin all of these. Take a little bit of yellow here. That's the input, so this is the output. You know, when I was a child, I'd make these drawings of creations that I wanted to invent, but I didn't have the technical expertise yet to build them. And so I'd always just be making these kind of cutouts. So who knew that I would end up, well, my parents might say they knew, making stuff like this. What I'm gonna wanna do, just to make sure I don't blow my circuit, we're gonna go down the line here and verify each little part. All right, so it's gonna be a little difficult with the way I wired this. Never mind. Pin 1 should be going directly to ground. Threshold and discharge are tied together. Trigger is tied to a pull-up resistor and transistor. If I charge this up right now, again, put on some glasses, before we attach our solenoid. Nice, it works. Okay. You have no idea how relieved I am just to see this work. All right. Come here, magic hands. So we're going to add our solenoid. Gonna get the ground. This is going across that biased resistor. So this needs to be pointed away from me for now. Such a great sound. Time for final assembly. So close. Oh, it's done. I can't believe it. It's done. All the screws are in. So not that bad, considering all that's sticking out of the gun right now is the CO2 cylinder. Got basically a safety. This is our final product. Not bad. Fortunately, it's a little late at night tonight, so I think I'm gonna call it quits for tonight. But tomorrow we're gonna totally test this thing out, and I'm super excited. You guys didn't see this shoot before, but this did great. Like when I was testing it and it was still disassembled, it went flying. Having the CO2 up back here helped so much on the feed issues that we were seeing on the gun before. So I will see you guys tomorrow and we will actually get this test done. So here we are at the end of our build. Time to give it a test. Let's charge it up. Going hot. Turn on the safety. Well, it's a shotgun. All right, so we're at about 15 feet. I don't even need fully automatic. It automatically comes out all at once. So let's try this again. All right. That is pretty accurate. I'm impressed. Instead of me having to shake the gun at all, now we have that gas backfill that helps push these forward, and it's pushing them forward so fast that we're getting multiple feeds through one trigger pull. This means that we can either reduce the amount of gas on the back, or change the timing of the circuit in future build to get less CO2 out. This will make the system more efficient. All right, I'm aiming for the left cup. And I don't even need to load this in all the way. Oh, maybe I do. Maybe I lied. What? I think I just blew up the marshmallow. That's because I wasn't aiming down the sight. This is letting off a lot of CO2 fast because I can feel this chilling already. Yeah, that is super accurate now. Oh, we might be running out of CO2 here. Yep, we're running out of CO2. Interesting. Oh, the CO2 has gotten this area of the gun so cold that it's making these things turn to rock. These things are flying fast enough. If you're watching closely, you can see that they've got a little bit of an arc to them, depending on which side has a little bit of drag. But we're definitely reaching the back wall. It's not as accurate. So after finishing the build and playing around with the gun, I'm super impressed. We made improvements on every box that we were trying to. The feed rate greatly increased. This has no problems feeding anymore and super accurate. I aimed at a single cup and I nailed it every single time. That being said, there are some improvements that I'm already looking at where the CO2 tank runs out relatively fast. The other downside to that is things tend to cool down and it's causing a jam. But easily addressed by some timing. I hope you guys had as much fun as I did. If you liked what you saw on this video, give me a thumbs up, subscribe. If you thought there were some improvements that could be made, just leave it in the comments below. And thanks so much for joining me. We'll see you next time on Re-Engineer Tech. All right, guys, so now that we're done on the range here, you can see that we've made improvements in all the key areas that we were looking for: accuracy, range, and rate of fire. We did this all while keeping within its original envelope, obviously minus the CO2 on the back end. The range is greatly increased while kind of taking away a little bit of the long range accuracy, but I'll take it because it's firing farther than it would have with the pump action. It's a lot more stable. I was able to aim down the barrel at a single cup and it hit it at the 15-20 foot range. That being said, we went through CO2 a little bit too fast in my opinion, so this means that we're probably going to be doing some upgrades to this later on, so keep tuned in for that. It won't be right away, but I'm looking at possibly adding adjustable timing to this because there was too much CO2 coming out and it was starting to cause the mallows to freeze and jam in the front. That being said, we had no feed issues in the hopper with this backfill of gas. So I'm super excited. I hope you guys had fun. I had a great time doing this. I learned a lot. I hope you did too. So if you enjoyed what you saw, give us a like down below and subscribe. If you happen to have comments on how we could improve, go ahead and leave it below as well. And as always, thanks for joining us here at Re-Engineer Tech.